Have you ever looked at one of those massive industrial plants and just wondered, what are they actually doing to protect the environment? It's not just some vague promise in a press release, right? No, it's a really complex, detailed system. So that's what we're going to do today. We're going to dive deep and demystify how these places manage their environmental footprint step by step.
Look, we need these plants. They give us power, water, all sorts of products we rely on every day. But let's be real, an operation on this scale with smokestacks and water discharges and waste, well, it comes with some serious environmental risks. It's a constant push and pull, a balancing act between production and protection.
And yeah, that really gets us to the core question here, doesn't it? How do you get all the benefits of industry without harming the planet? The answer, it turns out, isn't just one simple thing. It's a meticulously designed system of monitoring, control, and response.
All right, so here's our game plan. We'll kick things off with the environmental challenge itself. Then we'll break down the system of control. We'll get into the nitty-gritty of how they monitor land, sea, and air, check out the waste management plan, see what happens when spills occur, and then wrap it all up with the cycle of accountability that holds the whole thing together. Okay, first up, the environmental challenge. And this is all about defining the mission, which is not just about cleaning up messes after they happen, it's about constant, proactive vigilance, being on guard 24/7.
At the very heart of the whole operation is this principle: environmental monitoring and control. Now, this isn't just about following the local rules to tick a box. The goal here is to build a complete system for managing every single output: air, water, noise, waste, you name it, and making sure it all meets strict international standards. So, a great principle, but how do you actually make that work day to day? Well, that brings us to our second section, the system of control. You can think of this as the master plan, the central document that connects all the dots.
Now check this out. What you're looking at here is basically the brain of the entire environmental operation. This isn't just some boring diagram. It's a command structure. It takes every potential thing that could come out of this plant and links it directly to a specific monitoring procedure and response action. Nothing is left to chance.
And if we deconstruct that system, you find it's built on these 5 key pillars. The plan monitors air emissions from the stacks, effluent or wastewater discharges, stormwater runoff, the noise levels around the plant, and of course, every single piece of waste from the moment it's created to the moment it's disposed of. Each of these has its own dedicated playbook.
Okay, so that's the theory. But what does this all look like in practice? Let's jump into Section 3 and see how they monitor the land, sea, and air in their daily operations.
When it comes to air quality, they've got online monitors fitted to every single stack. And these things are continuously tracking pollutants like sulfur oxides, or SOx, and nitrogen oxides, NOx, in real time. For water, it's just as rigorous. Chemists are constantly taking samples at key points, from the seawater coming in to the cooling water going out, and they run a whole battery of lab tests for over a dozen parameters, checking everything from pH to residual chlorine.
And this is where you really see how far the monitoring goes. It's not just about what's coming out of a pipe. They actually check noise levels every quarter at the property lines just to make sure they aren't disturbing the area. And get this, they even hire professional divers to do underwater surveys of the local marine life every 6 months, all to make sure the ecosystem is staying healthy.
Now, all this industrial activity is going to create byproducts. It's going to create waste. And that brings us to a absolutely critical piece of the environmental puzzle, the waste management plan.
The entire plan is built around this globally recognized hierarchy. The best option, always, is to just reduce the amount of waste you make in the first place. If you can't reduce, you reuse. If you can't reuse, you recycle. After that comes recovering energy from the waste, and only as the absolute last resort do you finally dispose of it.
The very first step in managing all this waste is knowing exactly what you're dealing with. Everything gets strictly sorted into 2 basic categories: hazardous and non-hazardous. And getting this classification right is absolutely non-negotiable, because the way you handle them is completely different.
And the variety here is huge. Hazardous waste includes stuff you'd expect, like used oil, chemical sludge, and batteries, but it also includes things like old fluorescent tube lights and e-waste. Then on the non-hazardous side, you have all the everyday stuff like paper, plastic, scrap metal, and even food waste from the cafeteria. Every single item has its own designated path to follow.
But, no system is perfect. Prevention measures can sometimes fail. So what happens then? That takes us right into the emergency response plan for when spills happen.
This right here is the golden rule of the entire response. Report any spill immediately. The procedure is explicit. Don't wait. Don't try to get more information. Don't underestimate it. Speed is the absolute #1 priority.
The second a spill is reported, it gets classified. This table determines the entire response. For example, a Class C moderate spill is between 5 and 25 cubic meters if it's coastal, but only 1 to 5 if it's inland. That classification immediately tells the team the scale of the response and exactly which authorities need to be notified.
And just like the main environmental plan, the spill response has its own process map. This is all about making sure a potentially chaotic situation is handled methodically. From that very first notification, it guides the team step by step through assessment, containment, cleanup, and finally a deep-dived investigation to find the root cause. And that investigation leads us perfectly into our final section, the cycle of accountability. This is what ensures the whole system isn't just a plan on paper, it's a living, breathing process that actually works.
So how do you prove this system is actually working? With data, tons of it. Every measurement, every test result, every single kilogram of waste is tracked in these comprehensive monthly environmental monitoring reports. This document is the ultimate proof of performance. It's the bedrock of accountability.
And this is the final, crucial loop that ties it all together. If any of those parameters goes over its limit, whether it's an air emission or a water quality metric, it's not just noted down. It automatically triggers a corrective action and a formal investigation. And here's the so what moment. This isn't optional. Failing to report and correct these issues can lead to massive fines, legal action, and huge public backlash. The system is designed to learn from its mistakes, because the consequences of not learning are severe.
Which really leaves us with this final thought. In a world of incredibly complex industrial processes, is a perfect, flawless system even possible? Or is the true measure of environmental responsibility found not in achieving perfection, but in that relentless, never-ending cycle of constant monitoring, rapid response when things go wrong, and totally transparent reporting every single step of the way?